Hi everyone, this is Mr. Kachinga. In this video, we look at a circle theorem or property. It is based from examination question paper, that is 2022 paper 1 GCE question 17. So this is the question 17. In the diagram, A, B, C and D are points on the circumference of the circle. Center O, then BD is the diameter, AD is equals to AC, and angle BDC is equals to 22 degrees. So this is the information that we have been given, okay? And on my right hand side there are questions. Okay, so what they are saying, we have points A, B, C, and D. Then this O present the center. Okay, so then BD is the diameter of a circle. Okay, so the first question we find angle BAC. So when finding an angle, it is very important to follow the letters. You see, they say BAC. So we go on the diagram and locate BAC. So we go right, BAC. So what they want is A here. I'll put a red ink for you to see. So what they want is where I've put a red ink. Now, when you notice this 22 degrees and where I've put a red ink, they are on the same segment. I'm going to show you something to relate. So look at this. The angles in the same segment are equal. So when you look at this angle and this side, this angle, they are on the same segment. They are coming from the same segment. So similarly, this 22 which is here and where I have put a red ink, they are coming from the same segment. It means that also here there is a 22 degrees. If here you have a 22, it also means that that side there is a 22 degrees. Okay, so what you have to say, you just put that BAC is equals to 22 degrees. Okay, so angles in a same segment, they are equal. So that is the explanation. Then B, we have CBD. So on B, we are going to solve CBD. Okay, the target is B. Okay, now when we follow the letters, they are saying C, B, then D. So what they want is this. Okay, when they say CBD, what they want is the angle which is there. So to find the angle which is there, first we have to consider this property. Remember, they have said this is the diameter. So if it is the diameter, it means this side is a 90 degrees. But what they want is the angle which is here. You see that? The question says BD is the diameter. So the diameter, it cuts the circle into equal halves, meaning we are going to have a semicircle. So wherever there is a semicircle like this, if we cut this part, we cut it like this, we can observe that it will be a semicircle, meaning that here there will be a what? A 90, just like the way I've demonstrated here. Okay, now how can we find the angle which is there? The angle which is here. We know that the interior angles of a triangle add up to what? 180 degrees. When I say 22 plus 90 plus the angle which is there, I should be able to get 180. So this is what we are going to do. Just say CBD plus 90 plus 22, it should be equivalent to 180 degrees. Then CBD, first of all, we are going to add 90 plus 22. So this is paper 1. So I encourage you to solve without using a calculator, because in paper 1 we don't use a calculator. So when we add this, we should be able to get 112, then equals to 180. So we say CBD equals, we know that we cannot add this, so this will go to the other side. We have 180 minus 112. CBD is our target. From 180 we take away 112, so 180 minus 112 will get 68 degrees. So meaning on CBD here, on B, we have 68 degrees. Okay, so we have solved, meaning here there is 68 degrees. We continue solving. So C, we find the angle ACO. So let's follow the letters AC, you see that, then O. So which means they want this angle which is here inside. You see that? So this is the angle that they want. Now there was extra information given here. They're saying AD is equal to AC. You see that? AD. It means this AD is equal to AC, equal to AC. Okay. Actually, on the diagram, they were already there, these angles. Okay, or you can just interpret. When you look at the paper, they are there. Okay. So now, when they put these two things, okay, I've said they were already there. Okay, just like the way they are saying AD is equals to AC. It means that the base angles, they are same. By base, I mean that when you look at this triangle A, C, and D, it means the angle which is there, which is here, okay, the angle which is here, and the angle which is here, they are same. Okay, they are same. So for us to find here, where I've put a red ink here, we just have to know this angle. When we find this angle, okay, when we find this angle, then we'll be able to find the angle which is here. So it is easy, okay, because we know that here there is a 90 degrees. You see that? So we are going just to say 90 minus the angle which is here. Then we'll be able to find the angle, because this angle plus this red line, we should be able to get 90 degrees. So this is what we are going to do. Before that, for you to understand the concept, I will just demonstrate on a paper. I will show you what is going on. Okay, just a quick one. Well, what I mean is that from here up to this side there is 90. Okay, so if we find this angle which is here and subtract with 90, we'll be able to find the angle which is there. Okay, so what we have to know the angle which is here, okay, which is 68, then we'll be able to find this. Okay, so let's first identify the angle which is here. We know that this 68, it is in the same segment with the angle which is there, which means that also here there is a what? A 68, because this 68 and this 68, they are on the same segment. We know that angles in a same segment, they are what? They are equal. Okay, I want to show you this for you to understand. You see, we have 68 here, then also here there will be what? 68. I've just removed important part. You see that? You can see here 68 and there 68. Then the same 68 will help us now to find these angles which are same. So how do we find those angles? So this is how we find. We're going to say 180, take away 68, then divide by 2. Okay, why divide by 2? Because the angle which is here and this side, they are equal, they are two angles. So we say now 180, then take away 68. So we have to calculate. So when we calculate, we do that 180 minus 68 will get 112. Okay, then 112 we divide by 2. So 2 into 112 will be able to find 56 degrees. Okay, so this 56 degrees, it means that this side there is 56 degrees, also here there is 56 degrees. Okay, finally now we can find our destination angle which is there. Since we know that here there is 90, we'll be able just to subtract with 90. Okay, so finally there I would just say SCO is equals to 90 minus 56. Then SCO is equals, so 90 minus 56 will get 34 degrees. That's all. Okay, so these are solutions. The first one was 22. Angle is in a same segment are equal. Then BD we have used semicircle. Angle is in a semicircle. They produce 90. That's why you're able to see 90. Then this one we have used a lot of properties. So one of them, angle is in the same segment, and also we have also used then angle is in the same segment. Angle is in the same segment produce 90. Okay, you see, so it means that at this point there is 54, so that when we add 34 plus 36 we'll be able to get this 34 plus 56 we'll be able to get the 90 which is there. So this is one way that you can able to find this. But if you wanted, there are a lot of ways that you can find this. Okay, it is not the only way that we can able to find this angle which is there. If I wanted, I know that when you look at this OCD, you see that it is an isosceles triangle. I can see that this distance they are equal. It also means that here there is a what? A 22 degrees. You see that if here there is 22 and we know the distance from here is 56, I can also say 56 minus 22 for me to find the angle which is inside. Still, I'll still get a 34 degrees. You see that? So there are a lot of ways. All right, thank you for watching the video.